Hi, and welcome to the Database Design Chat number 12. Today I'm going to talk about random data versus scrambled data. And it came up from something I saw in the real world that made me think, I'm going to get back to normalization soon. I'm going on vacation. We're moving. Again, back in slightly less boring than last week. Digs. I'm going on another vacation. I vacation too much. Long year last year. But so I have a couple of lighter topics before I move back into normalization. First, just a little bit about me. If you want to know more about me, go to my link tree. That rhymed. Didn't mean for it to. But all my details are there. All right, so I was driving along today, and in my hometown, Tennessee, there were two cars sitting side by side with these brand new license plates. And they had a pattern of data that was so similar, it made me go, really? Now, I took these license plates, the left one here, on the sample webpage where they're introducing people to the new license plates. But what made me wonder is this really what they wanted? To have these two license plates, which are so very similar, in the same town. And I've seen more license plates that still have the same kind of thing where it's the same letter combinations or the same number combinations. Really, the numbers are usually in the first place and the letters are usually in the last place for these new license plates. So all the letters were the same and the numbers were different. And I was like, really? Is this what you want? Did they randomize? And then, is this possible? What if could randomly you get the exact same values? And of course you can, right? Randomness is randomness. And the weird part about randomness is that sometimes randomness doesn't look random. If you've ever bumped into someone who you're not good friends with one or more times in the real world, you've experienced this. So randomness is just randomness. But it's not always desirable because we have this thought. Computers are random, not at all, right? They're all based on an algorithm. Now there's the look of randomness, and randomness, as long as you don't know what the output's going to be, is relatively okay. But even using the rand function in SQL Server, you can control what values come out of that function by setting a seed. And now let's take a little look at that. I'm going to pop over to my remote desktop and say you have a random number generator and you want to just output random numbers. So we run this, and in the loop, I'm going to store in the table a value, which is a float. And I'm going to put that into a table. I'm going to run this 100 times. I'm going to get the output. And you can see the output's the same, is what it is, 0.8, 0.2, 0.7 for the first ones. I run it again. Now it's 0.6, 0.02, 0.22. When you're writing random code, that's good. Like, this is random enough. I don't have any control of what those numbers are, and I'm not tricking in any sort of way. But it is based on an algorithm of some sort. Maybe the clock ticks, maybe something else. So it's not as good as rolling a die in the exact same physical manner every time you get a different value, because it's a different set of physical inputs. Something is occurring in the background. Even the definition of this it says pseudo random value. But if you want to control that, and you want to do some testing, if I set rand, put a parameter to the rand function, and I only have to do this once, but every time I run this now, I get the same rand value every time. And if you look, 0.47, 0.94, 0.00, 0.947, 0.94, 0.00, every time I get the same value. So if you're writing some code and you need some random values, that's good. But what if I need to make sure these random values are shuffled? Is it curious in some respects that every single time you run a function, you don't occasionally get back the same series of values that looks like it's wrong? And I always find that interesting myself. It's the thousand monkeys with a thousand typewriters argument. No, a thousand monkeys with a thousand typewriters probably will not rewrite Shakespeare because it's so freaking many unlikeliness. And if you know anything about randomness, obviously anything that's not impossible, Hitchhiker's Guide to the Galaxy talking here, anything that's not impossible is possible, but however unlikely. Okay, so you can control a sequence, great for testing. When you want to make sure that a set of random values works, and then you want to see that it works again with the same 100,000 random values. You can check that out, or originally random values. But shuffled data, as I would suggest for the license plates, should not actually be strictly random. There may be patterns. You may need check digits. They may want all the license plates in a certain area to have a certain pattern, but having them have the exact same values to me is counterproductive, because you go out and you look at a car and I got their license plate. Well, it's exactly the same as someone else's, only one digit off, right? That's not what you're hoping for. You're hoping that no two cars are going to sit next to each other with the same pattern, so you can tell them apart if you have to do it. They're having some problems with the license plates not being readable by certain readers, which is good and bad. It's good if they're trying to catch you for speeding. It's bad if they're trying to catch, someone who's abducted someone. But anyhow, so we want to make sure that we're careful about that. The old thing comes up when you're playing cards. Someone says, "Did you shuffle them?" This looks like nothing's happened. Well, every time you shuffle, there's a likelihood that it's going to come out in perfect order. So if you look at 1 to 52nd factorial, it's a big, big, big number. It is a really big number. And I found this webpage, theedge.com. The 50th factorial is 3.04 times 10 to the 64th. So the unlikeliness of you actually coming up with the same order of cards, or any specific order of cards in a shuffle, is very unlikely. Even just one card out of place, becomes not the same pattern, but it's possible, right? That's the thing. It's possible. So when we build this kind of shuffle data, we want to make sure it's random. It's not distributed in a way we don't want. We don't want a shuffling machine, probably, to shuffle all the cards and have them all in the exact same order, or all in an order that we don't want them. Like ace through king and every suit. But is it possible? And at that point, is there a case where you start breaking the rules? You start doing things that are actually wrong by over shuffling certain kinds of data. Okay? Because computers cheat, right? We know people can count cards. Computers can count every card over and over. And that many permutation of cards is not as much to a computer as it is a person. And you could actually go in and set up and take the hands and then produce an order that looks shuffled, but knowing what everybody has and the possible plays outcomes. And then you take those possible permutations and you reduce them down to a set that looks safe. And then you have enough of them so no one actually sees that. So hiding this stuff is dangerous, right? in certain conditions. But you need to make sure that you're not doing anything that's illegal, not outputting random values that look the same. Like I said, I don't want 2 license plates in the same area to have the exact same values and plus one number off, because that'll be harder to tell apart. It is possible that 2 cars from the 2 sides of the state or someplace, they happen to be together and you happen to see that. That would be, that's magical, right? There's some magic in random occurrences, but it's not the goal. So when you're writing the software, when you're building random data sets, we want to make sure that they're random enough without being too random, but random enough not to be breaking some sort of laws or rules. All right. I hope that's at least clear or interesting. Or clear and interesting would be nice, but I'm only shooting as high as I can. Computers are only as random as you program them. We've all tried to build random things. You can take one of the seconds, you can get the milliseconds. You can do all sorts of things. And then just based on randomly when you fetch it, the clock ticks. But you have to be really careful and make sure that if the requirements say, always back to the requirements, right? We're always going back to that. The requirements say, I need random data, then it doesn't mean I need random data that is massaged in any way. But if you do need it massaged, you need to make sure that you tell the customer, here's how I'm massaging the data. I'm making sure that all the cards or all the rows don't show up in a certain order. If I'm randomizing names, I don't want every name to come out in alphabetical order for some reason. And if you're building a playlist, I don't want it to shuffle the same song with the same name in order, which is so very annoying, right? When you're playing a shuffled playlist and 3 or 4 songs happen to be in order, the same song played over and over, just a little bit different name or something. Okay. Again, correctness. Bang on that 100% of the time. Understand what a customer wants, what they want. Random data, they want shuffled data. They want it, kind of massaged in a certain way. And you give them what they ask for and what they want, not just what is expedient and easy. All right, if you have any questions, please send them to me. Comment on this YouTube channel, email me, message me on Twitter, contact me anywhere on my link tree. Next week, I'm going to do my best this time to put together a little video from Disney and Universal on a practice I used to do to whet my design thoughts. And it's corny. I'm going to put myself out here a little bit on this particular time. It's not as corny as this hat, but my hair was a little messed up. But the fact is, I'll be back with another video next week. And if not next week, it'll be the week after. Until then, see you later.